In this lesson, we're going to be looking at the difference between chemical weathering and physical weathering. So first, we're going to talk about what weathering is. Weathering is just where we break stuff down. So the words weathering and erosion sometimes get used together, and so people don't understand the differences between the two. Weather is if we break it down into the smaller pieces, and erosion is when we move those pieces. So right now we're talking about the breaking down part. It's a physical change usually. We have the chemical weathering that has a chemical change. What you're looking at here is a picture of the Grand Canyon, and the agent of erosion that has caused all this movement and all this breaking down and the weathering is the river, the Colorado River as it's moving through. So once again, we've got our mechanical weathering, which is when the rocks are breaking down into smaller pieces. It's still the same rock. So imagine taking a piece of paper, tearing it into half, tearing it into lots of little pieces. It's still paper. It hasn't changed the fact that it's paper. It hasn't changed the kind of the paper. We could tape it all back together again and it would still be paper. It just is the same thing. It's the same thing with rocks. It's like taking the granite, if you've got the little pink rocks or the tan colored rocks that are in your front yard. A lot of times they're used for landscaping. A lot of that is granite. It's the same granite, whether it came out of the side of the mountain, the crushed granite when it was part of the bigger rock, or whether it's in your front yard. If you take that piece of granite and you hit it with a hammer and you break it down and break it down and break it down, it's still granite. It hasn't changed the actual composition of the rock. There's a lot of different ways, because nobody's really out there hitting it with a hammer, so there's a lot of different ways that mechanical weathering happens. And the first one happens because of temperature. So in areas where the temperature changes during the year, unlike here where it just feels like, it's hot and then it's just not quite as hot, in areas where they have 4 seasons, where they actually have warm summers and they have freezing that happens in the wintertime, the water will get into the cracks of the rock in here during the warm months. And then during the cold months, when the water freezes, then it's going to push the rock apart because water gets bigger when it freezes. And so it's going to wedge apart, or it's going to push apart these rocks and cause cracks in them. And so this is called frost wedging. That's because of temperature. So here's our water filling in the holes in the rock. It's freezing and it's getting bigger and it's breaking the rocks apart. So this is called frost wedging. Sometimes nature, living things can act upon our rocks. One of those things that can happen is because of tree roots, so pressure. So we had temperature was our first one. Pressure is our second one. And so in this one, the pressure of the tree roots, which here's a tree root coming down in between here. Here's another one that you can see coming down in here. The tree root, when it's really small, it starts to grow into the cracks in the rocks. And then as the tree grows and the root grows, it gets bigger and it pushes the rock apart, just like the water did when it froze. The tree root does the same thing. It just takes a little bit longer because it takes time for the tree root to get bigger. Another effect of pressure is when you have layers of rock that are sitting on top of other layers of rock, and as they start to be exposed, they don't have all this stuff around them helping to hold up the weight. They don't have as many rocks around there, and so now all that pressure of the rocks on top are now directly on those rocks, and it causes them to crumble. This one is because of the pressure of gravity. It's called exfoliation. And here the rock actually comes off like in sheets, so it kind of peels its way off. Girls, I don't know guys maybe, but if you use like the loofah sponges and you're exfoliating your skin, right, you're taking off those thin layers of skin to make your skin look nice and healthy. That's the same thing that's happening here, is it's thin layers of rock coming off the top. So that was our mechanical weathering. Remember, mechanical is where we're actually just changing the size of the piece of the rock. In chemical weathering, in chemical weathering, we're actually changing the chemical composition of the rock. So we're dissolving it, we're exposing it to oxygen. We're doing something that's making the rock be fundamentally different. You can't put it back once you've had a chemical change. Just like if I put together all the ingredients to bake a cake, I get my flour and I get my butter and I get my sugar and I get my eggs and all of that, and I mix it all together and I make a cake and I bake it. I can't unbake the cake. I can't take it back and make it back into its component parts again. It is what it is because I've changed it. In my first example, when I said you could take that piece of paper and tear it up, if I burn that piece of paper, that's a chemical change. I tore it up, that was my physical change and mechanical weathering. If I burn it, now I've changed the chemical composition of the paper and I can't unburn it. I can't put it back to the way that it was before, and I've made it something fundamentally different. The same thing happens with chemical weathering. Chemical weathering is really important when we make sedimentary rocks because this is where we get all the glue that sticks together all the little pieces of our sedimentary rock. So water is one of our primary modes of chemical weathering. As it rains, the water leaches into the rock itself. If there's a little bit of acid rain in there, then it's going to start to dissolve the rock away. So you can see how this one had flowing water on it, and you can see how nice and smooth it is around the outside. That's usually a pretty good indication that wind or water has been in play. This one might look a little bit familiar if you remember back to the Harry Potter series. This was what they used in the second to the last movie. This was one of the areas where they filmed part of the movie. But all these little chunks of rock that are in here, they're separated because of the chemical weathering. They're separated because the water has dissolved away parts of the rock. Oxygen plays another role in chemical weathering. So when something rusts, like if you put out a piece of metal and it rusts, it's because it's been exposed to the oxygen. Water helps speed it up, right? And there's oxygen in water, and that helps speed it up, but really it just has to be exposed to the outside air. In a lot of our rocks, there are particles of iron in them. Remember we said in the core is mostly iron and nickel, and that iron comes out into the mantle, and when volcanoes erupt, the iron comes out of the mantle and becomes rocks, and it solidifies, okay, it hardens on the surface and becomes rocks. And then those minerals, as they get broken down, they get mixed into sedimentary rocks and they go through the rock cycle, and then we end up with iron in lots of our different kinds of rocks. And so as that iron is exposed to the atmosphere, it starts to rust or oxidize, and so it turns this pretty red color. Carbon dioxide in our atmosphere. Carbon dioxide has always been in our atmosphere as long as we've had one. There's varying amounts of carbon dioxide depending on what cycle we're in. Right now, obviously, we've got lots of carbon dioxide. It's a component of the burning of fossil fuels. When carbon dioxide gets up into the atmosphere and mixes with the water, it makes acid rain. So you can see it makes carbonic acid. The molecules kind of rearrange themselves up in the atmosphere. But then basically the carbon dioxide attaches itself to a water particle, and then it comes down to the surface. And when we put an acid of any kind onto limestone, it's going to dissolve the calcite out of the limestone. It's going to fizz. So you can use vinegar in a piece of limestone, and you can drop vinegar on it, and it's actually going to fizz. It's kind of a fun little thing to do. So, but a lot of things that in our past, in our human history, a lot of things that we carved out of were limestone. It's a relatively soft rock, which makes it easy to make things out of. And so when you look at this on the edge of a church, obviously a gravestone, you can see that one of the reasons why all the features start to go away or the carvings start to go away is because the acid in the atmosphere, when it comes down as acid rain, it dissolves it away. This is the same thing with sulfuric acid. So when sulfur dioxide goes up in the atmosphere, it combines with it and it does the same thing. We get carbon dioxide mostly from burning oil, gas, it's the natural gas and that kind of stuff. Sulfur dioxide we get from burning coal, also a component that comes out of our fossil fuels, our other fossil fuels as well, our gas and oil. Both of these come out of the eruptions of volcanoes, but not as much as what comes out of our tailpipes and out of our factories. So some more examples of what happens with carbon dioxide, also sulfur dioxide, doesn't just impact our rocks and the rock cycle, it also impacts the trees and the vegetation. Most organisms have a range of tolerance, what they can actually handle when it comes to the amount of acid that's in the water, what the pH level is or how acidic it is, and if it's too much, they're going to die. It's going to burn them. All right, so those are our two different kinds of weathering. We've got chemical weathering, right, which causes an actual physical change in the rock, and we have our mechanical weathering, which just breaks it down, okay, into smaller parts. Still the same thing. In Canvas, when you finish this video, you'll click the next button, and the next page will be a quiz. It's a Check for Understanding quiz. It's a formative assessment, which means it's just an assignment grade, but you're allowed to take it as many times as you need to in order to get that 100% to move on.